In this video, we will discuss the question number 5 of NBHM 2025. So question number 5 is saying that given a metric D on R2, the closed unit ball around 0 with respect to D is the set all such xy belongs to R2 such that D of xy 0 0 is less than equal to 1. So the ball is, if we write B 0 1, and as this is a closed unit ball, so I am writing B bar is equal to all such xy belongs to R2 such that D of xy 0 0, this is less or equals to 1. Okay, now the thing is that they are asking if D is induced by a norm which is which of the following shape can be the closed unit ball of 0 with respect to D. So the shapes are given by a rectangle, an ellipse, an equilateral triangle, and a parallelogram that is not a rectangle. So let's get started. So first of all, let's talk about the L2 norm on R2. If we have an element xy belongs to R2, so instead of L2 norm, let's discuss the L infinity norm. So L infinity norm is defined by xy infinity, which is equal to maximum of mod x mod y. This is a norm on R2. Now the thing is that if this set can be replaced as, which is equal to, as D is induced by the norm, so we can write all such xy belongs to R2. We know that for a nonlinear space, D of xy is nothing but the distance between x and y, right? So instead of that, we can write norm of xy minus 0 0, which is less or equals to 1. So which is equal to all such xy belongs to R2. On R2, if we subtract 0 0 from xy, you can write this is equal to xy. So norm of xy is less or equals to 1. This is what the given set is. Now, if we take this norm, infinity norm, so that is representing norm of xy is infinity, which is less or equals to 1, that is representing maximum of mod x, maximum of mod x comma mod y is less or equals to 1, that is representing mod x is less or equals to 1 as well as mod y is less or equals to 1, and which is representing that, or which is in other words, which is saying that minus 1 less or equals to x less or equals to 1 and minus 1 less or equals to y less or equals to 1. So that is representing the square about the 0, right? Now what we are going to do, we will scale this norm in such a way, right? If we take two non-equal non-zero real numbers like a not equal to 0, b not equal to 0, and a is not equal to b, like if I am taking 2 and 4, 2 and 6, then we can scale this norm as norm of xy infinity, which is equal to maximum of not only that, we are taking a special number, not a special number, we are taking the positive real numbers, a and b are two positive real numbers. Then we can write, so this against a function norm. Now in that case, observe that if we do the same calculation, we can write minus a less or equals to x less or equals to a, and minus b less or equals to y less or equals to b. So in that case, the figure changes to a 6 line between a and b. So this is y equal to b line, this is y equal to negative b line, This is x equal to a line, and this is x equal to negative a line. So that gives you the closed rectangle. So we need to scale it. If we scale L infinity norm, then we can find a rectangle. Now moving on to the second one, an ellipse. Is that possible? So for that purpose, we are talking about L2 norm. If we take the norm x comma y 2 norm, that is equal to all such not all such, which is equal to square root of x square plus y square. Now let us talk about the set b of 0 1, which is equal to all such xy such that norm of xy for L2 norm, that is equal to 1. So what I am doing, all such xy such that square root of x square plus y square, which is lesser equals to 1. So such xy such that x square plus y square is less or equals to 1. Obviously we are considering this now. So this is representing the circle, closed circle of radius 1 about the origin. Again, now we will scale this so that this circle changes to an ellipse. How we are scaling it? We are just changing this L2 norm in this form. Xy 2 is equal to x square by a, x by a whole square plus y by b whole square, where I am taking a not equal to b to positive real numbers or real numbers. Obviously, definitely a and b has to be non-zero. In that case, just observe that the same thing changes to as x by a whole square plus y by b whole square is less or equals to 1. At that time, we are getting this as an ellipse. So option B is also a correct option. Now we will discuss the option C later. We will talk about option D, parallelogram. Is that possible? Yes, possible. Parallelogram is also possible from this L2 norm. We will just change this. Sorry, not L2 norm. This is also possible from the L infinity norm. How? We will just change this L infinity norm as norm of xy is equal to um, mod of, if we take four real numbers, any four real numbers a b c d, such that ax plus by plus cx plus dy. Definitely what I am doing, I am fixing this a b c d, where a b c d are fixed real numbers, fixed real numbers. At the time I will get this as a parallelogram, that is not a rectangle. Okay, that closed unit wall b of 0 comma 1, that becomes a parallelogram but not a rectangle. You can easily check that as if norm of xy 2 is less or equals to 1, that is implying mod of ax plus by is less or equals to 1, and norm mod of cx plus dy, that is again less or equals to 1. So this is minus 1 less or equals to ax plus by less or equals to 1, minus 1 less or equals to cx plus dy less or equals to 1. Now note that this ax plus by equal to 1 and ax plus by equal to minus 1, these two are two parallel lines. So we are just considering these parallel lines as this one and this one, and cx plus dy equal to 1 and cx plus dy equal to minus 1. This is again a parallel line. Now if we take a matrix such that a b c d is non-zero, then this always, yeah, these two lines cx plus dy and cx minus dy will like this. So this forms a parallelogram, not a rectangle. So option D is also correct. That means we can also get a parallelogram, not a rectangle. Now, moving on to the option C, where is that from an equilateral? Is that possible that is an equilateral triangle? Now, if let us consider a case, let us take this possible. So these are our axes. Now, suppose this is an equilateral triangle like this. Now, what I am doing, note that if x comma y belongs to b of 0 comma 1 bar, it means norm of xy is less or equals to 1. What can we say about minus of x comma y? Now minus of x comma y, if we take the norm, that is nothing but norm of x comma y, which is again less or equals to 1. Now if we are taking, now if they are saying that is an equilateral triangle, like if we consider this point as 1 0, and we can also find out two different points as that this forms an equilateral triangle. At that time, note that minus 1 0 is not within the triangle, right? We can always consider construct a triangle whose vertex is like a0, but minus a0 is not inside the triangle. So equilateral triangle is not possible. So thank you for watching this video.